For our first example in Lesson 5, we're going to take a look at the gradebook case study once again, and this time we'll enhance it slightly to be able to calculate the class average for a class of specifically 10 students, each of whom can receive a grade of 0 through 100 on the exam. Now, before we get into the source code, let me just go ahead and show you this one in action. So I'll do start without debugging. And notice that right away we display the welcome message for the gradebook, and it includes the course name as part of that message, just as we had shown you in the last version of the gradebook case study in the preceding lesson. Now, we have to enter 10 grades, so we know in advance precisely how many grades need to be input. So this is what we call counter-controlled repetition. So let's go ahead and enter a bunch of grades now. So we'll do 88 and 79, 95, 100, just doing a variety of grades so that we can calculate the class average here. Okay, and a 10th grade. Now, after entering 10 grades, when I press enter, then it tells me what the total of all the grades was, and it shows me the class average. And the first thing you'll notice is that the total was 848, and clearly when you divide 848 by 10, you should get 84.8. But the class average was displayed as 84. And the reason for that is we're processing the grades in this example as integers. And in integer division, when you divide one integer by another integer, the result is an integer, a whole number result. And basically what it does is it simply truncates the floating point part of the value. So 84.8, the 0.8 is truncated, and we're left with the value 84. In the next example, where we introduce sentinel controlled repetition, we will also use floating point numbers so that we can get a proper class average calculation. Now, at this point, we have not studied arrays yet, so the gradebook does not store these grades in the gradebook object. Instead, it has one new method that we've added called determine class average, which we'll look at momentarily down here. And the determine class average method is going to perform the complete task of getting all the grades, calculating the class average, and displaying the result. When we get to the arrays chapter, we'll take a look at two more robust versions of the gradebook in which we actually store the grades in the gradebook, which is a more realistic representation of the class. So let's first take a look at the gradebook test class just to see how we use the gradebook. As you can see here, the code for testing the gradebook in this example is very straightforward. We create a gradebook object that we're calling myGradebook, and we assign that variable a reference to a new gradebook for the course name CS101, Introduction to C# Programming. We then tell the gradebook to perform a task. Remember that once you have an object of a class, you invoke its methods or its properties in order to perform various tasks. In this case, we're invoking the display message method that takes no parameters and uses the course name that the gradebook was initialized with as part of the message. And then we have the call to determine class average, which will do the input and calculation and display of the results. Now, one of the things that's common in object-oriented programming, for those of you who are just getting into object-oriented programming, is that because the data and functionality that you're manipulating are often encapsulated or wrapped into an object of a class, as you interact with that object, you often get very straight line code where you simply say to an object, do something, do something, do something. In this case, display the message and then determine the class average. And then all of the logic is embedded into the methods of the class. So it's very common to see this kind of straight line code when you're interacting with objects of classes. Let's go ahead and take a look at the gradebook class. And just to refresh your memory on the class itself, here at line 9 we have an auto-implemented course name property that represents the course name as a string and provides the default get and set accessors. So we're not doing any special logic in those accessors. Therefore, we're letting the C# compiler generate a private instance variable for us and the get and set accessors for the course name property to manipulate that instance variable. Our constructor for the class is again called gradebook, does not return a value. It is declared public, as is the course name property, because we would like the gradebook test class or any class that's using the gradebook to be able to access that course name property or that gradebook constructor. If the constructor is not public, then other classes cannot create objects of the gradebook class. And remember, by the way, that once you define your own constructor, the compiler no longer provides the default constructor that takes no parameters. If you also want to be able to create a gradebook with a default course name that is perhaps the empty string or just a null reference, then you would have to now define an overloaded gradebook constructor that has an empty set of parentheses rather than a parameter. Within the gradebook constructor, we still simply assign the name to the course name property. Our display message method has not changed from the last version of it in the previous gradebook example. All we're doing is outputting welcome to the gradebook 4 and the value of the course name. And the new feature in this class is the determine class average method, which starts at line 26. Now, once again, it is a public method because we want to be able to call it from our gradebook test class. It returns void, so it's going to do all of its work inside the body of the method and display the results from this method. And as you can see, it's called determine class average with capital D, capital C, and capital A for the naming convention of the method. It takes no arguments because either it's using data that's already in the class or because everything it needs is defined in the body of the method. In this case, everything is defined within the body. Now, the first thing we did was declare several variables at the beginning of this method. The first thing you should know about variable declarations that are local to a method is that you only need to declare them just before you actually use them. So I did declare them all at the beginning of the method here. We have an integer called total where we'll store the sum of all the grades, an integer called grade counter that we'll use to count from 1 through 10 so that we know that we've read in the 10 grades as required. We have an integer called grade where we store each grade as its input, and an integer called average where we store the average of all the grades. I certainly could have declared total right here at line 34 where I'm assigning it the value 0, and grade counter here at line 35 where I'm assigning it the value 1 to initialize those variables, but I chose in this particular case to declare them right up front. It's generally considered a good programming practice to declare a variable as it's needed, and no matter what, you must declare it before you actually use it. So one of the reasons that I declared the variables at the beginning of the method here was to be able to break up the rest of the method into phases for counter-controlled repetition here. The initialization phase where we get set up, the processing phase where we read in the grades, and the termination phase where we calculate and display the results. So the first thing we did was set total to 0 and grade counter to 1. Remember, local variables of simple types like int are not initialized. In fact, local variables in general are not initialized until you explicitly give them a value. So I have to give total a value before I can start using it in calculations down below. And of course, we have not yet read any grades, so we set it to 0 initially. The grade counter is initialized to 1 because we're going to be counting 10 grades as we do our input. And here is the while repetition statement. Now, if you're coming from a C-based language, you should already be familiar with the syntax that you're seeing here. The while keyword followed by a set of parentheses containing the condition. This is the so-called loop continuation condition. As long as it remains true, the loop keeps executing. And the body of the loop, which is a set of curly braces containing statements, defines the statements that I should execute repeatedly. The curly braces are only required if you have more than one statement in the body of the loop. If you have only one statement in the body, then you don't need those braces. But again, it's generally considered a good practice to always include those braces. Now, within the body of this loop, we're going to prompt the user to enter a grade. We will read in that grade, and we've certainly looked at this type of statement before. We read a line of text, pass the resulting string to convert.toInt32, which is going to convert the string to an integer value, and that will be stored in grade. And as you can see on this line of code, we're not doing any error checking of any kind, so we are assuming the user types an appropriate whole number value for the grade that's being input. If the user does not do that, then this program will fail with an exception, and again, we'll cover exception handling starting in the arrays lesson. At line 42, after reading in the grade, we add the grade to the current total and store the result in the total, and at line 43, we add 1 to the grade counter and store the result in the grade counter. Later in this lesson, we'll talk about the increment, decrement, and compound assignment operators that would allow us to shorten these statements at lines 42 and 43. After reading in the 10 values in the loop, line 47 calculates the average by dividing the total by 10. Again, because the type of total is int, and because the type of 10 is also int, struct system.int32 is the .NET representation of the int keyword in C#, if you will. So the whole number 10 is also treated as an int. An integer divided by an integer results in an integer, which means that we're going to truncate any floating point part to the average, which you saw in the output. We'll store the result in average. And then finally, we do a couple of console.writeLine statements that display the total of all the grades and the class average of those grades.